All right, so I was just asked to do one of these exercises of conditional probability. So we're gonna do number 4. That was the question, right? Do number 4. All right, so find the probability that a person chosen at random is in A but not in both A and B. So we have to work with this Venn diagram, right? Let me write the Venn diagram in the board and I'll show you how to do it in a second. All right, we have one circle. This is A, another circle, which is B, and the intersection. No, I'm sorry, the universe. Beautiful. And the values are 12, 6, 6, 10. 12, 6, 6, and 10. All right. Let me change into this configuration now. There we go. Hopefully you guys can see the board now. All right. So this will be the Venn diagram, right? And the first question was, find the probability that one of the students is in A, but not both in A and B. This is the one we're doing, right? Is in A, but no, both A and B. All right, so what we are asked right now is to find here the A. The probability that I pick a student and it is in A, so it belongs to this circle, but it cannot belong to A and B at the same time. So this intersection here, we're not gonna count it, right? That is the that is the question, right? That is the problem. Take a student that it belongs to A, but don't belong to A and B at the same time, which means the intersection. Remember, A and B at the same time is the intersection. So to do that probability, we're gonna begin with the total. Remember, the total is everything inside our diagram. So we have 12 plus 6 plus 6 plus 10. Every single possibility is denotated for every single number in every sector of the diagram. So 12 plus 6 plus 6 plus 10. This will be 12 and 12, 24 and 10, 34, right? That is our total of possibilities. This is the amount of total possibilities, right? From here, let's think about the ones that are successful for us, the ones that we want to find. All right. So the question was, again, find the probability of students that belong to A, right? If I pick one, that student belongs to A. So from here, you might be thinking, right, the ones that belong to A are 12 and 6. Those are the ones that belong to A, right? Remember, this little sector over here is in both A and also on B. So this sector is also on A, right? 12 plus 6. But the question said, the student has to belong to A, but no A and B at the same time. So we are not going to take 6 into account, which means our success is 12 alone. From here, we have our probability, 12 over 34. If you leave it like that, you will have good marks in your exam. But we can work it a little bit further. We can simplify this thing. If we do half on top and half down, right? We're going to have 6 over 17, right? 6 over 17. This will be our probability. Beautiful. Let's continue with the second one, B. What was that? B is not on A, right? Find the probability that a person chosen at random is not on A and not on both. Not A, not both. All right. As usual, let's begin with our total. And since we are working with the same Venn diagram, we are working with the same total. So 34. But now the success is the ones that are not on A and not on both. So how many of these numbers, which of these numbers are not on A? Okay, well, 6 and 10 are not on A, right? This 6 is not on A. This 10 is not on A. So we have 16 possibilities that are not on A, right? But is that the question? Let me see it again. Yes, not in A and not in both. All right. So these ones, 6 and 10, are the ones that are outside A, right? These two are outside. They are not in A. Beautiful. how many of those are not in both? These ones are the ones that are in both A and B. So these 12 are not in both. These 6 are not in both. These 10 are not in both. So what I have to think is, do I count the 12 or not? No. Because remember, the question said you have to take into account the ones that are not in A and also not in both. By just in this example, by not taking into account the ones that are, by taking into account the ones that are not in A, so the ones outside A, you did the rest already. So the solution will be 6 and 10, the ones that are outside 10. So 16 over 34. Again, remember, don't just do the success, do the fractionary. It will happen to you. Some of you would just say, all right, the solution is 16, and that's it. And that is a mistake, right? Remember, the probability is from 0 to 1. So a fractionary. But we haven't finished, right? We can simplify this thing. If we do half, just like we did on top, if we do half, we're going to have 8 over 17. This will be our probability, the final probability, this one. A, B, C. All right, let's continue with Z, with C. See the question. Let's find the probability that a student is not on both A and B. Is not on both A and B. All right, let's think about that. We are looking for the ones that are outside A and B. It's not on both, right? But both makes reference to the intersection, because we're looking for the ones that are on both. Okay? These 12 are only on A. They are not on both. These 6 are only on B. They are not on both. These 6 over here, these ones are on both, right? So these 6, which are on both, are the ones we are going to exclude. The question says the ones that are not on both. So which numbers in here are not in this sector? 12, 6, and 10. Those are the ones that are not in both, right? Beautiful. So our probability, again, since we are working with the same Venn diagram, we have the exact amount of total possibilities, right? But the success will be just 12 plus 6 plus 10, right? Now, how much is that? All right, 12 plus 6 is 18 plus 10 is 28. 12 plus 6 was 18, sorry. So 28. Just like Fabian in the chat said. But we can do it even further. We can simplify these two things always. Try to simplify whenever possible, right? If we simplify, we're going to have just by half, by doing half on top and down, we're going to have 14 over 17. Again, just like Fabian in the chat said. Beautiful stuff, right? Beautiful stuff.
Could I have a question?
Yes, sir. Yes, absolutely. Yes, sure.
Like in the quiz in Moodle, the answer will be simplified or like
Look, we mathematicians, we like things the easiest way, the easier possible way, right? That's how we like it. And that is where the word simplification comes from, making things simpler. So yes, if you can, you must. So if you say these are the answer in the quiz, in today's quiz, if you say this is the answer, you will have a mistake. You need to simplify it as much as possible.
Thank you.
All right. All right, let's continue with D. D. Let's find the probability that a student is in A, given that they are not in B. And this is where the fun part begins, given that they are not in B. This is a condition, right? So we are doing conditional probabilities here. We're going to find the probability that a student is in A. That will be our success, that a student is in A. But in order for that student to qualify, that student has to have a condition. The condition is the student cannot be on B. The student cannot be on B. That's it. That is the condition. So let's take a look at our diagram. Whenever we have conditional probabilities, the easiest possible way of answering those exercises is by taking a look at the diagram and creating a new diagram. We are going to delete, to erase some things from this diagram to make things easier. All right. What we're going to do is focus our attention on the condition. Now, the condition for that example is not in B. That is our condition, right? Okay, so let's think about which of these numbers are not in B. Is this 6 on B or not? Well, yes, right? Look, that is the circle from B. So this 6 is in B. We have to erase that one. The condition is not in B. So we are going to erase everything that does not carries the condition. We are going to erase this 6 because it is on B, and we are going to erase this other 6 because it is on B. Our diagram now, our diagram changed. This is the diagram for the people who actually take into account the condition. These 12 take into account this condition. These 10 take into account this condition. So from here, the first and most important difference is that now our probability, the total, is going to change now. Before, the total was always the same because the diagram was always the same. We had the same amount of possibilities. But now, we only have 2 possibilities. Look, we only have 12 and 10. 12 plus 10 is 22. So our total amount of possibilities changed because of the condition. Now, out of those 22, how many are in A? That was the question, right? Let's take a look at this. That was the question. Look, how many are in A? That is the success. Sure, it has a condition, but we just did the condition. We just reorganized the diagram for the condition. So now all we have to do is answer this question. So what is the probability that a student belongs to A? Only these. These 10, they don't belong to A. Only these ones. So 12 over 22. And just like so many of you have been saying in the chat, we can be simplified this. This can be simplified. If we do half, we will have 6 over 11. So congratulations to the people who got the answer correctly. 6 over 11. Now,
I don't understand why did you change the diagram.
All right, I'll do it in a minute, right? I'll show it in a second. Again. Guys, I'm having the same difficulty again. Sorry. I'll try to explain it from here. The reason why is because the condition, la condición, hace que ya no vaya yo a mirar todo el diagrama. La condición me hace que me enfoque solo en las personas, en los grupos que cumplen la condición. Por eso ignoro todo lo demás, lo ignoro, eso no existe, eso no me cumple la condición. ¿Sí? Yo estoy seguro que en este momento, si les pregunto, ¿cuántos de ustedes tienen perro? Varios me levantarán la mano. Pero la condición, si yo pongo una condición, el total de personas que tienen perro cambiará. Porque solo algunos de los que cumplen la condición tendrán perro. Si yo digo, ¿cuántos de ustedes tienen perro? No sé, la mitad de pronto me dicen yo. Pero si digo, ¿cuántos de ustedes tienen perro? Dado que son ustedes, son hombres, pues ya no la mitad de personas me dirán que tienen perro. Algunos. La condición delimita el grupo de personas que tengo. Delimita el conjunto. Aquí la condición es no estén en B. ¿Ok? Las personas, los elementos que no están en B son estos 12. Esos no están en B, mira, están por fuera. Y estos 10, esos tampoco están en B. Luego, entonces,
pero entonces no era necesario borrarlo, ¿no? Como que se puede identificar a simple vista.
Por supuesto, claro que sí. Claro que sí. Solo mirando se puede, por supuesto. Ahora, No todos tienen la habilidad de solo mirar y resolver el ejercicio. Para algunos esto es importante. Entonces, por eso lo hacemos. A medida que vamos haciendo más ejercicios, más buenos nos volvemos y ya ni siquiera dibujamos. Ya en la mente se puede ver. Pero es de a poquitos. Guys, from here on, I cannot access the chat. Sorry, guys. I don't know what's going on with my Google Chrome. This is a problem of Google Chrome. I have no idea what's going on. This is the reason why we lost the meeting at the beginning, why I had to leave the meeting at the beginning. So if I continue working on this, I think everything is going to be fine. But if I try to access the chat and try to see who's working and who's not, then I'm going to leave the meeting again, and I don't want that, all right? So, sorry, guys. Sorry, I cannot see the meeting. Sorry, the chat, sorry. Let's try to do the next question, this one. Find the probability that a person chosen at random is in B, given that they are in A. Given that they are in A. So we have our condition now. The condition is the students are in A. Let me just continue with the main diagram. Now, the information of the diagram was this is 6 and this is also 6, right? And this is the set for B, right? Now, we're doing the question E. Find the probability that a student is in B, given that the student is in A, right? Is in B, given that they are in A. Beautiful. So now, let's try to, without erasing anything, because I feel like you guys want to do it that way. So without erasing anything, let's try to think about how many people how many people take that condition into account. How many are in A? Okay, these 12 are in A, right? So these ones, these take the condition into account, right? How about these ones? All right, these ones are in B, but they are also in A. These ones are in A. These 6 take the condition into account. This 10 over here, these 10 take the condition into account as well, right? So what we have is a total of 12. I'm sorry, these 10 are not in A, right? These don't take the condition into account, right? So only these 12 and only these 6. So 12 plus 6, that will be our total, 18. And now, out of those 18 people, only these 2, how many are in B? Again, you might be thinking these are in B and these are also in B. Yes, but the condition makes it so that our focus of attention is only on these 18. We're going to forget about these 6. So out of these 18, how many are in B? Well, only 6, right? So 6 over 18. Just like we did at the beginning, we can simplify this. We can simplify it. We can find the third, right? Not half, we can divide by 3. We're not going to divide by 2, we're going to divide by 3. So if we divide by 3 this time, we're going to have 2 over 6. All right.
Profe.
We divided by 3. Yes.
¿Por qué 18?
Again, the 18 will be the amount of people who take the condition into account. All right. So our condition, we're doing a different example, right? Our condition is the ones that are in A. That is the condition. Look. Given that they are in A. That is the condition. So how many people in this diagram are in A? 12 and 6. 18 people. That would be the total.
Profe,
Yes.
entonces, digamos, para resolverlo podríamos hacer como, pues está la frase y sería primero mirar como después del given that y ahí eso es lo que seleccionamos y ya vemos qué es lo que le incluye lo otro. Y
Yes.
para la parte de abajo sería la probabilidad de la condición. ¿Sí?
Perfect. Yes. Excellent. Perfect. Beautifully done. Yes, Gaby. All right. Always try to begin with
Gustavo?
the condition and then from there you can work. Yes?
A question. Sí. Sorry. In the case of the simplification, we need to simplify it at the most we can, or
Yes.
only one?
No,
At the most.
add as much as you can. In this case, I simplified by 3. The solution was this, but I could continue simplifying. I could do half, so 1/3. That is as much as I could. So that is the solution. So, Isa, did you get it? Isa Olier.
Sí.
Okay, beautiful.
Es que estaba. Casi me muero. Estaba leyendo el que no era. Entonces, por eso fue como, creo que 18.
Okay. All right, let's continue with the last one, all right? The last one. Find the probability that a student chosen at random is not in A, given that they are in both. I'm sorry, given that they are not in B. This is the condition. They are not in B. So let's take a look at that first. What would be out of all this diagram? Where are the numbers? What are the numbers that are not in B? That is the condition, right? Not in B are 12 and 10, right? So our probability, F. We have a total immediately. Remember, down will be the amount of the probability, of the condition, sorry. So not in B means 12 plus 10. We have a 22 as our total, 22. Now, out of those 22, let's see the question again because I forget it. Is not on A, not on D. Out of those 22 who takes the condition into account, out of those 22 which are the condition, how many are not in A? Only this 10, right? These 12 are in the condition, but they are in A. And we want them to not be in A. So 10 alone, right? So our success will be just 10. The probability, 10 over 22. But we can simplify. So if we simplify by half, we're going to have 5 over 11. We cannot simplify any longer. So this will be the solution, 5 over 11. That is a conditional probability explaining the easiest form possible. There are formulas for everything that we did in here. There are formulas. But I find that it is a lot easier to do it this way just by looking instead of having to use the formulas. If you use the formulas once, you're going to have to spend a lot more time. And two, I don't know. Maybe you like doing formulas. So if that is what you like, you can go ahead and do it. But I don't like using formulas. Mathematics is not formulas, right? Mathematics is thinking, analyzing, using logics. So I find it is a lot more interesting. All right, guys. So I'm going to stop the recording here. This was the example for probability, conditional probability. If you have any more questions, let me know, guys.
Gus, yo tengo una pregunta.
All right, yes, tell me.
En lo que hiciste, el de arriba no sería solo 10. Es que me confundí porque ahí dice como is not in A. O sea que no está ni en A ni en B.
What question?
La última, la F.
All right, so is not in A, right? It's not in A.
O sea, de lo que yo entendí, pues no está en ninguno de los dos. Entonces solo sería el 10.
Yes.
¿No?
Beautiful, yes. That
sí,
is what I have here.
El de arriba,
This is F. Look,
por eso 10. Y el de abajo tampoco, el de abajo también sería 10, ¿no?
Oh, no. Because the one that goes down is the condition. Look, always in the denominator, you will have the condition. Look, the condition is everything that is after the word or the words given that. This is the condition. So the one down is this, the ones that are not in B. Got it, Juanita?
Sí, señor, gracias.
All right. So,
una cosa, en los ejercicios de como que son como de lo de los dados y lo de los dados, no, lo de las monedas, ¿puede haber algún ejercicio de condicionalidad en lo de las monedas? O
absolutely,
sea,
yes. Yes, absolutely. It depends on what question the person asks. Yes, I could, okay. I don't know, on the top of my head, I could say, what is the probability of getting three heads, given that I throw 4 coins? There we go. That's a conditional probability. Now, those two events are independent. So the probability, the conditional probability in that case is the same as the probability alone. But it can happen. All right. Maybe when we get to those type of exercises, I'll show you a little bit more into that. As of now, I feel like all you should worry about are these type of exercises. That question, the question that you had, may happen in the future, and when it appears, then we will study. But as of now, it's a little bit redundant, right? The events are independent, so the conditional there doesn't really matter. We'll see it in the future.
Okay.
We'll see it in the future a little bit more, right? Again, guys, if you have more questions, ask away, please. Otherwise, I'm going to stop the recording now. All right.